In the silence of a battlefield sky, far above the Earth, a missile slices through the air at blistering speed. To the untrained eye, it almost looks magical. A small, precise dart that seems to know exactly where its target is, no matter how fast or far it tries to run. But there's no magic here. What you're seeing is the result of decades of science, engineering, and strategy. A blend of physics, electronics, and computer intelligence working together with one singular purpose: never to miss. Modern missiles are far more than just explosive projectiles. They're sophisticated machines, almost like robotic hunters. Their job is not simply to fly forward. Their job is to think, to adjust, to chase. Unlike bullets, which simply follow the path of the barrel and lose speed as they travel, missiles are guided. They constantly talk to themselves, and sometimes even to their operators, making thousands of calculations every second to stay on track. Let's start with the brain of the missile, its guidance system. The most common systems are GPS-guided, laser-guided, infrared-guided, or radar-guided. Each of these has its own unique way of telling the missile where to go. GPS-guided missiles work just like the GPS on your phone. They know their exact position on the Earth and the exact coordinates of their target. As they fly, they adjust their fins and thrusters to make sure they stay on the most direct path to those coordinates, even if wind, gravity, or enemy defenses try to push them off course.
What's even more fascinating is that some missiles can think ahead. They don't just aim for where the target is right now, they aim for where the target will be. This is called lead pursuit. For example, if a fighter jet is flying at Mach 1 and a missile is chasing it, aiming directly at the jet's current position would cause a miss, because the jet would have moved by the time the missile arrived. Instead, the missile's onboard computer calculates the jet's speed, direction, and possible maneuvers and predicts the perfect intercept point. It's almost like a chess player thinking several moves ahead, except the missile is doing it in milliseconds. And then there's mid-course updates. Some long-range missiles can be talked to after they're launched. A radar system, a drone, or even a satellite can send updated information mid-flight, telling the missile if the target has changed direction or speed. This keeps the missile relevant even in a fast-changing battlefield, where targets may try to hide or escape. But perhaps the most awe-inspiring technology of all is found in terminal guidance, the final few seconds before impact. In this stage, missiles often switch to the most precise sensors available. Some have cameras that literally watch the target and make last-second adjustments. Others use millimeter wave radar that can see through clouds, smoke, and bad weather. This is the moment where the missile's entire job comes down to a single point, no matter what, hit the target. Of course, there's a psychological side to this too. For soldiers, pilots, and even civilians, missiles represent both fear and reassurance. Fear because they are so accurate. If you are the target, escape is nearly impossible. But reassurance because they can end a threat with incredible precision, sometimes saving lives by preventing the need for larger, less accurate bombs. Missiles have evolved over decades to get to this point. In World War II, the German V-2 rocket was the first guided missile, but it was not very accurate, often missing by miles. By the Cold War, missiles became smarter with the invention of inertial guidance systems, radar seekers, and later GPS. Today, some weapons can strike within a few feet of their intended target from hundreds of miles away. And the future? It's even more advanced. Hypersonic missiles, capable of traveling more than 5 times the speed of sound, are now being developed. These weapons are so fast that current missile defenses struggle to stop them. Pair that speed with AI guidance, swarm tactics, and real-time satellite data, and we may be entering a world where a missile can hunt its target almost autonomously, adapting mid-flight like a living predator. But despite all this technology, there's still one thing that never changes: the human element. Behind every missile launch is a decision, a strategy, a choice. Someone decides when and where it will fly, and that decision can change the course of history. So the next time you see a missile streaking across the sky on the news, remember, it's not just a weapon. It's a flying computer, a precision machine built from decades of science, and a reminder of just how far human engineering has come to ensure it never misses.